Good afternoon, students. Today we are going to discuss about flip-flops. So what is a flip-flop? It is a memory storage device. How much memory it stores? It stores 1 bit memory. It stores 1 bit memory. It is a memory storage device. Okay? And the basic thing that we must know about flip-flop is here the present output depends on previous output. So always a flip-flop is a sequential logic circuit. There are two types of logic circuit. One is your combinational. Another one is your sequential. Combinational means earlier you all have studied about mux, demux, encoder, decoder. These are combinational logic circuit and this is a sequential logic circuit. Flip-flop is a sequential logic circuit. The basic difference is only here in case of combinational logic circuits, the present output depends only on the input. But in case of your sequential logic circuit, the present output depends on previous output. Okay? So what is a flip-flop? It is a 1-bit memory storage device. Now let us see one by one how many types of flip-flops in general we use daily. First is RS flip-flop. So RS flip-flop I am showing you with the help of a basic NAND gate. We all know NAND gate is a universal gate, right? So this is a SR flip-flop. As you can see here, both the outputs are again interconnected as input. Alright? So now let us see how this RS flip-flop works. So this is the truth table of an RS flip-flop. Let us fill one by one. Okay. Now see, the first case is S is 0, R is 0. So in the definition I told what? Present output depends on previous output. Right? So let us suppose earlier as we did not connect any circuit, so earlier the output is 0. Let us see. If we don't give any connection, ultimately does we get any output? No. So let us consider the previous output is 0. Okay. So if this is 0, see, if this is 0, this is 0. 0 into 0, how much? 0. In case of NAND gate, what we will get the output? What is the output of a NAND gate? It is A dot B whole bar. So 0 into 0, 0. 0 bar means 1. So Q bar we get 1. Now see, this is 0, this is 1. What is 0 into 1? 0. Again 0 complement 1. See, this is 1, this is 1. Is that possible? No, because see what I had written here, Q and Q bar. If Q is 0, Q bar must be 1. If Q is 1, Q bar must be 0. But what we are getting? Both are equals to 1. So it is an indeterminate case. This is an This is an indeterminate case. Okay. Now, when S is equals to 0, R equals to 1. S is as same as 0, R is 1. So in the previous case, what we got? 1, 1, right? Now see, this is 1. 1 into 1, 1. Its complement will be 0. Right? 0 into 0, 0. Its complement will be 1. So what we are getting? When S is equals to 0, R equals to 1, we get So, let us again do one more case. Again, I am telling about 0 and 1 only. Once again, let us see. So, first case, let us consider Q is equals to 0, the earlier output. Now, if this is 0, this is 1. 1 into 0 is 0. 0's complement, 1. Again, 1 into 0, 0. 0's complement, 1. Again, like this, here, what will happen? Whatever the output will come, it will ultimately depend on the previous output. When S is equals to 0, R equals to 1, we get a case where we get Q is equals to 0. If Q is equals to 0, ultimately what is Q bar? It is 1. This condition is known as reset condition. So reset condition will only happen when R is equals to 1 and S is equals to 0. When S is equals to 1, R equals to 0, we get Q is equals to 1 and Q bar equals to 0. This is a set condition. And the last one is when the both inputs are 1, 1. When both inputs are 1, 1, as I had written, there is no change. No change means, for suppose, if earlier we saw this set case, we get output as 1, 0. Then, if we will keep 1, 1 again, there will be no change. Same output it will show, as you all have done in your lab. If we will see the reset case and then we go to 1, 1 case, again, the output will show as that of the reset only. Means, in case of when both the inputs are equals to 1, there is no change in the output. Whatever the previous output is, it will come as it is. Okay. In some books, instead of writing 0 and 1, they write it as low and high. Low means 0, high means 1. Okay. So this is about your RS flip-flop. Now let us see the next is JK flip-flop. This JK flip-flop is an extension to RS flip-flop. So see, we have to take one RS flip-flop. This is the basic JK flip-flop circuit diagram. So as you all can all see, up to this part, this is an RS latch. To this latch, we are connecting one more latch, that is a two NAND gates with help of a clock pulse. Here, JK flip-flops requires clock pulse. Clock pulse means if the clock pulse is 0, whatever the inputs we will give, it will not care at all. It is a don't care option. And this don't care is noted as cross mark. When clock pulse is 1, then only we get the outputs. Okay? And the general symbol of a JK flip-flop is Q bar. Okay? Now, let us see how this JK flip-flop works. Okay? So, if clock is 0, whatever the output it will be, there is no change. Sorry, whatever the input is, there is no change. Okay, we will get a don't care option. Input in the sense, either it may be 0, 0, it may be 0, 1, it is 1, 1, 1, 0. Whatever the values of J and K, we get the output as don't care. Don't care indicates it does not show any output. Okay, now when the clock pulse is 1, the first case is 0, 0. It is same just like that of your RS flip-flop. When there is 0, 0, there is no change. Okay? Again clock pulse 1 and your condition is 0, 1. J is 0, K is 1. Then we get this Q is 0 and this is 1. This is a reset condition. This is a set condition, and when both the inputs are same, we get a toggle condition. So reset condition, we all know reset will only occur when R is equals to 1, right? So reset condition means how we will get in case of JK flip-flop. The J must be 0, K is equals to 1 means J must go low and K must go high. If we name these gates as G1, G2, G3, G4, when if you observe low at G1, high at G2, we get a reset condition. For set condition, we have to do the reverse. That is, high at G1 and low at G2, we get the set condition. And the last one is your toggle. Last one is a toggle means both the inputs are high. Toggle means, for suppose if you get the previously Q equals to 1 and Q bar equals to 0, when we will apply the clock pulse 1 and J equals to K equals to 1, we get the output as Q equals to 0, Q bar equals to 1. Means it will just toggle, it will just transfer the output into its complement. Earlier Q was 1, so now after toggle we get Q is equals to 0. Earlier Q bar was 0, we get 1. For suppose earlier Q is equals to 0, Q bar equals to 1, we get after toggle Q equals to 1 and Q bar equals to 0. In simple definition, if we say, if we get a reset condition earlier and we do the toggle operation, then we will get set condition. And if we earlier output is set condition and if we will get the toggle, then the present output will be reset condition. Okay? So this is all about your JK flip-flop. And your D flip-flop and T flip-flop, these are nothing but the extensions of J and K. If we join both J and K, then that is a D flip-flop. And if we join both R and S, then we get a T flip-flop. That we will discuss in the coming classes. Thank you one and all.